All right, this is the Geometry Semester 1 in-class review, day number 2. So we start with M is parallel to N, and we want to prove that angle D is congruent to angle E. Okay. Now, again, as I mentioned in class, really, since we know the lines are parallel, we know that angle D is congruent to angle E by the alternate interior angle theorem. But the idea here, I guess, is that we're trying to prove the alternate interior angle theorem. So they just pick D and E, and what it really should say is prove that alternate interior angles are congruent. But they basically want us to show that they're congruent by showing that D is congruent to E. So in summary, we can't use the alternate interior angle theorem here. We have to use other things to show that the alternate interior angles are congruent. All right, so we start off with our given here. So we know that for step 1, M is parallel to N. Okay, and then for our reason, that was given to us. Given. Okay. From there, we want to find a way to get from D to E without going directly from D to E. So we want to probably pick something that's congruent to D. So maybe H, right? Those are corresponding angles. So we know since the lines are parallel here, that D and H are going to be congruent. And that is the corresponding angle theorem. So if we come over here for step 2, for step 2, am I going to have an enormous amount of problem with this? Whatever, 2, we're going to have angle D is congruent to angle H. Right, and that's going to be your corresponding angle theorem, which says if corresponding angle theorem, which says if the lines are parallel, then the corresponding angles are congruent. Okay, we're now at H. We're trying to get to E, so we can go straight from H to E. Those are vertical angles. Okay, and the vertical angle theorem tells us vertical angles are congruent. So step 3 here is going to say angle H is congruent to angle E. And the reasoning there for us is that vertical angles are congruent. That's the vertical angle theorem. Okay. Now we know that D is congruent to H and E is congruent to H, right? Two things are congruent to the same thing. We can use the transitive property to say that angle D is congruent to angle E. Right? If two things are equal to the same thing, then they're equal to each other, right? And then, right, if two things are congruent to the same thing, then they're going to be congruent to each other as well. So if H and this should be, I totally messed up here, angle 8E. Oh no, angle D and E. I don't even know what, I didn't even put angles in. Okay, which is what we're trying to prove. Angle D is congruent to angle E here. Right, so we started off with the lines are parallel. We can't go straight from D to E because that's what we're trying to prove. So we need to go indirectly from using other things to get D congruent to E. So we said D is congruent to H by the corresponding angle theorem. And then we said H is then congruent to E by the vertical angle theorem. And since D and E are both congruent to angle H, we use the transitive property to show that they're congruent. You could also use the substitution property. So instead of putting an H here, we could substitute in E because we know E is congruent to H. So step 4 also could have been the same thing because of substitution. Right? But make sure on the test you don't put alternate interior angle theorem here. Right. All right, the next one wants us to show, to prove that B is congruent to G. So this is going to be the same basic process. So step 1 here, we're going to do M is parallel to N. That's our given. Lowercase m. Okay. Step 2, so we're trying to get from B to G, so let's start at B. Okay, we can pick anything that's congruent. Again, we can do corresponding and then vertical again. But let's just do vertical and then corresponding to switch it up this time. So we'll do B and C are congruent by vertical angle theorem, and then C and G are congruent by corresponding angle theorem. And then again, since they're both going to be congruent to C, we can use the transitive property. All right, so angle B is congruent to angle C by the vertical angle theorem. B is congruent to C. Okay, and then C angle C is congruent to angle G by the corresponding angle theorem. Nope. Can't put a period in there. Corresponding. Okay, and since B is congruent to C, and since G is also congruent to C, we can use the transitive property then here. Or substitution, but on the test it's going to say transitive, right? It'll be fill in the blank, so the blank option they'll give you is transitive property. We can say angle B is congruent to angle G. Okay, since B and G are both congruent to C, they're congruent to each other by the transitive property. Again, B and G are alternate exterior angles. And essentially what we're trying to do here is prove the alternate exterior angle theorem. So we can't use the alternate exterior angle theorem to prove that it's true, right? You can't assume something's true in order to prove that it's true. You have to use other things to show that it's true. So here we're going to use vertical and then corresponding and then the transitive property. All right, this one's very similar here. C and E are same side interior, so we know they're supplementary. But we can use, right, we're trying to prove, the idea is we're trying to prove the same side interior angles here are supplementary. So we can't use the same side interior angle theorem. We're going to have to use other things. All right, so let's start with our given. So step 1 here, M is parallel to N, and that is your given. Okay, step 2. So let's start at, you usually want to pick something that's congruent. So let's start at C. Okay, and we can pick a lot of different things here that are going to be congruent, but let's just pick F, I think, is a good one. Okay, so C and F are alternate interior angles, so we know they're congruent, so we can say that angle C, right, so we can say, oops, put the 2 in there. And this is where, you know, we should really say angle C is congruent to angle F. Right, but what they're going to do on the test is they're going to skip a step. So they're going to say the measure of angle C equals the measure of angle F. Okay, and they're going to say that because of the alternate interior angle theorem. Again, I don't like the inconsistency, but I think that makes sense, right? Really, you should say angle C is congruent to angle F. Right, and then you should say by the definition of congruent, the measure of angle C equals the measure of angle F. But that's fine. Alternate interior angle theorem. Okay, I'm gonna, yeah, that's fine. All right, and then F, we're trying to get to E, so if we go from F and E, that's a linear pair. Okay, so we can say that the measure of angle F plus the measure of angle E is going to equal 180. That's your linear pair theorem. Okay. Nope, don't want that. Linear pair theorem. Okay, again, we're skipping a step. We're combining 2 steps into one. I don't really like that at all, but that's what we're doing. Okay, it really should say definition of linear pairs, F and E are supplementary, and then by the linear pair theorem, the measure of angle F plus the measure of angle E is 180. Right? And then we're going to simply substitute in now. Right? So if the measure of angle F plus the measure of angle E equals 180, and the measure of angle F equals the measure of angle C, we can simply say the measure of angle C plus the measure of angle E is going to equal 180. That's substitution. Substitution. Okay. And then since they're add up to 180, that's going to mean that angle C and angle E are supplementary. So angle C and angle E are supplementary, which is what we're trying to prove. And that is your definition of supplementary. Okay, and again, it'll be drop-down menus for you on the test, so that should be simpler. Okay, we're not going to go over that. All right, next thing we want to go over is what ways we have to show triangles congruent. So let's write the ways on the side here. Okay, we have side, we don't want text. Okay, we have side, side, side. Right, we have side, angle, side. We have angle, side, angle. We have angle, angle, side. And we have HL. Right, these are the 5 ways we have to show that triangles are congruent. Right, the ways that don't work here, angle, angle, angle. Angle, side, side. Or side, angle, angle. I'm sorry, side, side, angle. Right, these don't work. Okay. All right, so let's do the problem here. So here we have 2 pair of angles. We can add the reflexive property, and those 2 would be congruent by side, angle, side. You have a side, and then an angle, and then a side. So that's side, angle, side. Okay, right? You have a side, angle, side. Side, angle, side. Okay, here we're going to use side, angle, side. Again, right? I'm sorry, I don't know what I'm saying. Those are angles. Right, this is an angle. So there's 1 pair of angles. There's 1 pair of sides. And there's another pair of angles. Right, so that's angle, side, angle. Okay. Over here you have a pair of sides. So here's a pair of sides. Here's a pair of angles. And then here's another pair of sides. So you have side, angle, side. Okay, here you have a shared side, so you can use the reflexive property. And now you have 3 pair of sides, so that's side, side, side. Here you have vertical angles are congruent, so we can add those in. We know that's absolutely true. Here's 1 pair of angles. Here's another pair of angles. And then here's a pair of sides. So we have angle, angle, side. Angle, angle, side. Okay. Over here, here's a pair of angles. Whoop. What's going on? All right, here's another pair of angles. And then here's a pair of sides. So that's going to be angle, angle, side. Okay, over here you have the reflexive property. So you have angle, side, angle. Right. So this is a pair of angles. Then you have a pair of sides here. And then you have another pair of angles. So angle, side, angle. Okay, down here you can use the reflexive property. And now you have side, right? A pair of angles here, and then a pair of sides. So that's side angle, side. Okay, and then here you have 3 pair of sides, so that's going to be side, side, side. Okay, side, 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 side. Right, you could even put that in here and here. Side, side. Second pair of side, here's a third pair of sides, so side, side, side. Over here you have 1 pair of sides. You have 2 pair of sides. 3 pair of sides congruent, so you have side, side, side. Okay. All right, the next part here says, what additional information do we need in order to show that the triangles are congruent by side angle, side? So right now we have a pair of sides, and we have a pair of angles. So we have a pair of sides, we have a pair of angles, which means we need a pair of sides such that that angle is between them. So the pair of sides needs to be UV and PR. So now you have, right, a side angle and then a third pair of sides. Okay, so we need PR, segment PR needs to be congruent to segment VU. Okay. Over here we can use the reflexive property. So now we have 1 pair of angles, right, and then 1 pair of sides. So we need another pair of angles, okay, such that the side is not the included side. So if we pick these 2 sides, that would be side angle, side, angle. We want angle, angle, side. So we need to pick angle B is congruent to angle D. That's going to be our second pair of angles here. All right, so we need an angle B to be congruent to angle D. That way you have angle, angle, side. Okay, C here. Right, we have 2 pair of sides, right, which means we need a third pair of sides. So we need EG to be congruent to L to NL. So EG, segment EG would need to be congruent to segment NL. Okay, over here we have 2 pair of angles. Well, these 2 are congruent, and then X and Q are congruent. Angle X and angle Q. Okay, that means we need a pair of sides, and that pair of sides needs to be between the 2 pairs of angles. So it needs to be segment XY and segment PQ. So XY needs to be congruent to QP. Okay, and that will give you your pair of sides. So you have angle, side, angle. All right, next question, write a triangle congruent statement. So again, you can name the first one 6 different ways. So I'm just going to do this one up here. Actually, we'll do it below. Okay, so right here, we'll do triangle. How about KJL? Right, so there's 6 different ways you could have named it. KJL, KLJ, LKJ, LJK, JKL, or JLK. So 6 different ways to name it. Doesn't matter how you do it. Okay, but then the second one, you have to match up the corresponding parts. So K here is a right angle. So K is going to match up with M. J is next. J has 2 arcs, so J matches up with N. Okay, and then L matches up with L. Okay, so there would be a good triangle congruent statement. All right, for this one over here, I'm just, again, 6 different ways to name it. I'm just going to name it ECD. So that's got to be congruent with triangle, and we have to match up the corresponding parts. So E here in the first triangle has 3 arcs. So we need to match up with the 3 arcs in the second triangle, which is going to be D. Okay, C here has one arc, so that matches up with F. And then D here has two arcs in the first triangle, so it's going to match up with the two arcs in the second triangle, which is E. So triangle ECD would be congruent to triangle DFE. All right, the next one here, let's do it in a different color. All right, so AB here, we can do this without drawing it if we want, but if we wanted to draw it out, we certainly could draw it out. So actually, let's probably draw them out. So let's draw them, I guess we can draw them here. Okay, so A, B, C. Okay, and then A matches up with D, E, and then F. Okay, so AB here is going to match up with DE. So segment AB would be congruent to segment DE. Right, AB and DE. Okay, BC would match up with EF. So segment BC is congruent to segment EF. Okay, and you could use the diagram for that, or you can use the statement, either way. Okay, and then AC is going to match up with DF. So our third side here, AC, would match up with DF. So segment AC is congruent to segment DF. Okay, and then our corresponding angles. So, you know, we can name the first one here angle BAC. Right, so angle BAC is going to be congruent to angle EDF. Right, angle B up here, right, angle ABC is going to be congruent to angle DEF. DEF. Okay, and then angle BCA. So angle BCA is going to be congruent to angle EFD. Right, and you could have also said just angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. That would have been fine as well. Okay, and that's it for day 2. We'll do one more for day 3.